Hey everybody, this video is going to talk about finding the average rate of change of a function. Now, the question is going to look like find the average rate of change of a function. I'm going to give you a function from a x value to an x value, okay? But let's talk about what that even is. So when we're talking about finding the average rate of change of a function, we're typically talking about a nonlinear function, okay? But we're going to use a line within a certain interval in order to determine the average rate of change between a function. What does that look like? Well, we're from one point to another, okay, we're going to draw a secant line, and what we do is we find the slope of that secant line, and that becomes the average rate of change of the function. So, the average rate of change of a function is the m, or slope, of the secant line between 2 points. Now, how do we find the slope between 2 points? We took the change in y over the change in x. Now, why does this say f of x2 and not y2? Well, this is the function value at this x point, the point x. And what we, in the problem, what we're given is a function, right? F of x. And so we need to use this notation in order to represent that. So if we move on to this problem, what I'm actually going to first do is I'm going to draw this function. Okay, so this function, now you don't need to know how to draw this. I'm just doing this for visualization purposes. At least not yet. You don't need to know how to draw this. But this function is going to go like this. Okay, and this point right here is x equals 1. And it's not drawn to scale right now, and that's going to be x equals 3. And then x equals 2 actually happens to be right here, so definitely not drawn to scale. A little bit of a funky axis there. But so if we want to find the average rate of change of this function from x equals 1 to 3, what we need to do is we need to find the secant line, or the slope of the secant line, between those 2 points. Now, this is going to be the point x2, y2, and this is going to be the point x1, y1. But how do we find that y1? Well, I know that x1 is 1, because that's what I need to find. My x2 is 3. So how do I find this point right here? Well, that's wherever the function, right, wherever I plug in that x1 or that x2 into my function and get my y value out. So f of x1 is f of 1. And then I just plug it in. So that's 1 cubed minus 3 times 1 squared plus 2 times 1. Now, I know from the graph this should be 0, but we're not going to be given a graph. So 1 cubed is 1 minus 3 times 1 squared, which is minus 3 plus 2. So 1 minus 3 plus 2 does equal 0. So f of x1 is that point, and that happens to be 1, 0. F of x1 is 0. What about this one? Well, let's plug in that second point, or that second x value, and we get f of 3. So that's going to be 3 cubed minus 3 times 3 squared plus 2 times 3. So this is going to equal 3 cubed minus, this is essentially 3 cubed, so that goes to 0, plus 6. So my second point is 3f of x2, which we found was 3 and 6. So how do we find the average rate of change? We haven't even done that yet. Well, that's the slope of the line between these 2 points. So that's going to be f of x1, which we found was 0, minus f of x2, which we found was 6, over f of x, or x1, which is 1, minus x2, which is 3. And you might be saying, hey, the formula was f of x2 minus f of x1 over x2 minus x1. Guess what? Doesn't matter which order you do it in, as long as you keep x2 and x2 over each other and x1 and x1 over each other, it's going to be the same thing. So this, we could also do f of x2, which is 6, f of x1, which is 0, over f of x, or x2, which is 3, and x1, which is 1. So we should get 6 over 3, 6 over 2, which equals 3. So that is the average rate of change of my function between x1 and x3. Now, ask yourself, what does the average rate of change actually mean?